From steak to roller coasters and Botox to electric cars.
Oh my God, it's so fast!
Each week, we showcase the new Irish science behind an aspect of modern life. On tonight's show, we find out 10 things to know about the science behind beef and beer. What makes Irish beef so great? Kathriona finds out if the secret is in how the meat is chilled and aged. Jonathan learns that the answer may lie in genetics. And I take a look at the science behind that perfect accompaniment to beef, a glass of beer.
Irish beef is considered amongst the best in the world. I'm meeting Michelin-starred chef Alain Alders at his beautiful restaurant in the Netherlands to find out why.
Alain is a member of Board Bia's Chefs Irish Beef Club, whose award-winning chefs give pride of place to Irish beef by serving it in their restaurants.
We try to work with products from this region, but the beef is not good enough. So we have our own lamb, we have our own deer. Only for the beef, we take it from Ireland.
So you source everything locally except your beef?
Yes. This is the Irish beef. You see this nice fat on it. I make it already, prepare it. And now we're gonna cut a piece of it and put it on the big green egg.
Beautiful. So if you're looking at an Irish steak versus a Dutch steak, how can you tell the difference?
The Irish steak, the color of the beef, the meat, is more intense red. When you look to the fat, it's more yellow because they eat fresh grass. The most important thing when you eat beef, or it's Dutch beef, or it's Irish beef, or American beef, the cow has to be a good life. When the cow has a good life, it eats good fresh grass, not dried grass, not too much cereals, just fresh food that gives a good life to the cow. In Ireland, there's a lot of space, so the cow can walk and eat fresh grass. When the cow is enough walking, he builds up muscles. That gives good beef.
So this stuff, our lush green grass, gives Irish beef its sought-after flavour, colour and taste, making it so popular abroad with chefs like Alain. But it seems the grass has health benefits too. It's rich in healthy nutrients that get converted into fatty acids by the bacteria in cow stomachs and get absorbed into the beef. When we eat the beef, we in turn benefit from those good fatty acids.
Do you only like steak served rare?
Medium rare.
Medium rare,
Yeah.
okay. If someone comes in and asks for a well-done Irish steak, you send them home?
A well-done steak, throw it away. Yeah.
It's pointless.
Yeah. Hey, taste it.
Wow,
Go to the table.
beautiful. Can I taste it?
Of course, go to the table.
Thank you, Vincent. Delicious. One of the reasons I love Irish steaks so much is because it's so tender. So now we're going to find out the science behind the perfect steak. They say it's what happens to an animal after death that has the biggest effect on how tender the meat on your plate will be. I'm investigating the science behind this and a new breakthrough by Teagasc, which will help predict how tender your steak will be. Paul, you're a meat scientist. How important is the handling of the animal after it's been killed in terms of its tenderness?
Yeah, well, evidence would suggest that about 3/4 of the variation in tenderness in particular is due to what happens to the animal after slaughter.
That much?
Yes. The main factors are chilling. It's very important to chill the carcass slowly. If you chill it too rapidly, then the muscles contract and then that meat will never be tender again. Another factor is hanging. The traditional hanging method is to hang the carcass by the Achilles tendon, such as these carcasses here. And it's taking the normal curvature. An alternative method of hanging is called H-bone hanging, where it's actually coming from the pelvis, such as this carcass here. So as you can see now, the tail is pointing straight up. The curvature's gone out of it there. And that's because all the stresses are being put onto the back here where the expensive muscle is.
So all those fillet steaks and strip loins and ribeyes, they're all getting stretched nicely.
They're all being stretched, so the fibres are stretched, so therefore it's more tender.
To be honest, I thought it was all about aging. That was the only thing I knew was influenced.
No, that's the next thing. Aging is probably the most important overall, really.
Aging is a natural process. Enzymes in the meat break down the muscle fibres, making it more tender.
Up to about 14 days, the tenderness improves quite dramatically. Then beyond 14 days, any improvement is very, very small.
So when I'm spending a fortune on a 35-day aged steak, I'm possibly, well, I might be getting the benefit of flavour, but...
You're guaranteed to be getting a tender steak, and also probably more flavourful because the flavour develops more with time.
Okay. I never knew how much science goes into making a steak tender. The way meat is handled really does make a difference to its tenderness. And now Paul Allen and his team at Teagasc have developed a new method which can actually predict how tender a steak is going to be.
Paul took me to Teagasc's Food Research Centre at Ashtown to find out more about this development. The current method for measuring tenderness is slow and tedious and labour intensive.
We're going to measure the force required to cut through this with this machine here, which is an instrument fitted with a Warner Brasler shear force device.
Warner
Brasler
shear device.
Force device.
Is it like a guillotine?
It's like a guillotine, yeah. So it comes down slowly with this V-shaped blade, and it cuts through the core and measures the amount of resistance in newtons from the steak. Below 40 newtons is tender. Anything over 45 is really a bit tough.
We tried it on 2 steaks, and the results showed that one steak was much more tender than the other. In the name of science, I had to taste the 2 steaks to check that the results were accurate.
So this is the tough, untender steak. Oh, how disappointing.
I mean, that's not even the highest shear force we can get. I've seen as high as 90, which I just wouldn't want to put that on my shoes even.
Then I checked the other steak.
Oh, this is pretty tender. Delicious. Good cook and a good scientist. I like it.
Good combination.
The drawback with measuring tenderness using the old shear force test is that it's laborious and time-consuming and impractical to use on every single carcass. Now, Paul and the team at Teagasc are working on a new way of measuring tenderness, using an infrared probe, which will predict how tender 2-day-old meat will be in 14 days' time.
It shines a spectrum of light in the near-infrared region, and it measures the light reflected back. And that spectrum has information in it which software, clever mathematics can extract and tell us the difference between a tender steak and a tough steak.
So what do you do? How does it work?
Okay, it's very simply we just place the probe onto the meat surface, press go, it's collecting the reflected light, and it comes up on the screen.
Oh my God, that's so much easier than the old method.
But this new method is still in development. Paul and his team take the results from their experiments to see how tender the 2-day-old meat is using the probe and compare them with their findings on how tender the meat is when it's 14 days old, using the old shear force guillotine test. Then they use the information to build a mathematical model to predict tenderness, which could transform the industry.
And why is this such a great breakthrough?
Well, for instance, if they know that a certain steak is going to, or a carcass is going to give tender steaks, they can say, well, that steak, we'll assign that to the best markets, we'll age it for 21 days to be absolutely sure, and we can sell that as guaranteed tender. Ones that are maybe intermediate, they might say, well, we'll age that for 14 days, won't bother aging any longer, and we'll send that to the middle end of the market. And then the ones which are never going to be tender,
of being tender,
they will go to manufacturing or whatever, like, a lower value product. This could improve the eating quality of Irish beef into the future forever. Like.
That's really impressive.
We already know that treating and feeding cattle well has a big impact on the quality of meat that they produce. And given that the beef industry is almost a third of agricultural output, it's pretty big business. The problem is that right now, the farmer doesn't know exactly how good that steak is until it's on the plate. And of course then, it's too late. Heinz Eggert has been a beef farmer for over 25 years. Back in the old days, how could you tell your calf was going to be a great calf for a good steak?
I could only tell by the cow and the bull I was breeding together and hoping to use the best genetics, but I'm not always sure I'm getting them. Basically, you have to wait a year when you see the animal growing up and see what this animal is doing. Is it going to be a nice animal or not?
That's a lot of time to waste.
It is, yes, absolutely. It's time-consuming, yes.
Thankfully, science is helping to speed things up. The Tully Progeny Test Centre monitors animals to identify the most desirable breeders. Certain traits are more desirable than others, and so they collect data on many different traits, like how much an animal eats and how fast it grows. Once you've gathered up all this information, what do you do with it?
Yeah, so this information then all feeds into a national database, and this database is run by the Irish Cattle Breeding Federation, and from that then they produce profit indexes or Eurostar indexes on all the animals in the country, all the beef animals, and they rate the animals on a 5-star system, with 5 being the best for a particular trait and 1 being the worst. So farmers look at this system, and this is typically a bull that farmers would use. It says basically that he's 5-star for docility, so his calves are going to be quiet. He's 5-star for carcass weight, for conformation, so they're going to have good attributes when they're slaughtered in the abattoir. And ultimately, he's a very good bull. So when farmers look to breed their animals, they're going to look at this star system to identify the most profitable animals to use in their cows.
So if I wanted to buy a bull, this is the bull I want to buy?
Yes.
Irish scientists are taking things a step further with genetics. Dr. Donagh Berry and his team of scientists at Teagasc are working on groundbreaking research to take the guesswork out of breeding by predicting which animals have the best genes.
Genetics is probably like the foundations of a house. You have to have good foundations from which you build the rest of the house, and it's exactly the same in animal breeding. So you can do all the best grassland management that you would like, but if you don't have good foundations or good genetics, then it'll be all a waste of time.
Scientists have already identified the genes associated with some traits, like fertility and growth rate. Now they're trying to identify the genes for others, like what makes tasty meat.
Up until recently, most people would have thought that how you manage the animal prior to slaughter and also during the slaughtering process and also how long you hung the animal for was the sole determinant of the quality of the meat. But we now know, based on the research that we've recently completed, that actually 20% of the differences in meat eating quality is actually due to genetics or DNA.
Wow, so there's quite a lot of nature in there with the nurture.
Exactly.
For their research, they compare an animal's DNA data with the practical information they've gathered. This helps them identify which genes in each animal are associated with particular traits. I took a DNA sample to send to the lab. Okay, easy fella. Just like getting an earring.
Once the sample arrives, the tissue itself is punched out of the collector. The tissue is broken down and the DNA is extracted out of that sample. That DNA then, once it's cleaned, it's washed across what we call a snip chip, and in the machine, that chip will tell us the DNA profile of that individual for over 50,000 pieces of DNA across its DNA.
Then have we identified genes that make a steak more marbled, or is that a long way down the road?
No, there's no definitive genes have been found yet, and that's where our research focuses on for the next 1 to 2 years, is to generate a database, probably the largest database in the world, of meat eating quality and DNA information. And that'll allow us to apply the technology we've used up until now for growth rate and fertility, and simply just transfer that and apply it to meat eating quality. And that'll allow us then to breed for better quality meat over the generations.
Through DNA, you can test an animal and can say that test will be very accurately telling you what that animal will do in its lifetime, whether it's good for beef or whether it's good for breeding. It's not messing with nature. It's just fast-tracking your prediction of what animal you're going to breed.
These scientific advances in genetics are helping to speed up the evolutionary process. And eventually, it looks like we'll even be able to predict how good our steak will taste on the plate. You know, I never realized all the different things that go into making the perfect steak. And knowing what I know now, I don't think I'll ever look at a piece of Irish beef the same again.
Irish people love steak, but a huge debate is raging about eating meat and the demands it places on our planet. To help with this, can we switch from getting our meat not from the land, but from the lab, potentially by using test tube burgers? To make these, first you need stem cells. These are like transformers and can change into any other type of cell. In this case, stem cells are taken from a cow, converted to cow muscle cells. Next, these muscle cells are grown in a scaffold. This allows the muscles to grow in 3 dimensions to replicate how they would normally grow in the body of an animal. But it is not enough just to grow. Muscles need exercise. Incredibly, this is done using mechanical stretchers, where the muscles are anchored to Velcro and pulled. And finally, the muscles are seasoned, colored, and minced into hamburgers. From petri dish to dinner plate, this sounds weirdly straightforward, but surely there's a catch. Of course there is. The first lab-grown burger ever produced came with a sizzling bill of €300,000. And while it looked and felt like meat, it didn't quite pass the taste test. But the fact remains, we have a huge problem: how to feed the world. And the lab-grown burger might just be part of the solution. See you next time.
When you think of Irish food and drink, Guinness is likely one of the brands that springs to mind. It's exported and brewed all over the world, and surely every visitor will have tried it at some point. But in the last decade, there's been a new kid on the block: the Irish craft beer. Craft breweries tend to be small and independent, using a mixture of traditional or innovative brewing ingredients. There are now more than 60 of them in Ireland alone.
Well, I have yet to meet a brewer who doesn't consider his or her beer to be a craft beer, because brewing is a craft. I think that's why you find brewers are generally a happy bunch, you know. We get to have a bit of botany, a bit of biology, a bit of physics, chemistry, all sorts of scientific, and then the art of getting the flavour and the balance right, you know.
I really do like that. My granny will be giving out. I shouldn't be having pints. Is there something distinctive about Irish craft beer?
The best in the world. Yeah. No, I personally think there is, because we have our sort of our bar culture and our style of consuming beer. You know, we like to socialise and stay out for the night and drink a few pints, right? So whereas a lot of craft beer that's developed abroad will be relatively high alcohol, high flavour as well, but very much to be sipped and savoured. And like we have an element of that, but I think we tend to produce more sessionable, maybe lower alcohol craft beers. So we're striving to get the balance of flavour, but not too high in alcohol.
Delicious. The best way to understand Irish craft beer, apart from tasting one of course, is to visit a brewery. O'Hara's in Carlow was set up 20 years ago, making it one of the pioneers of Irish brewing. Founder Seamus O'Hara tells me about the ingredients and the processes that go into making a craft beer.
This is wheat. Wheat is used, it gives a certain amount of texture to your beer mouthfeel. Then we have malted barley, which is really our base ingredient for most of our beers. We have flake barley, and this one is roast barley, which is pretty important to us because certainly for our stouts we use quite a chunk of this, which gives that kind of coffee, roasty flavours as well as the dark colour. Yeah. It's a little bit bitter. Tart, yeah. So another really important ingredient are the hops, and these give the bittering and give some of the aroma.
Gorgeous smell.
Yeah. Also, hops are a natural preservative, so one of the reasons hops were in beer originally would be partly to help preserve the beer. Alcohol is also a preservative, so in effect beer is a very natural preserved product.
Apparently,
Yeah.
they used to drink beer more than they did water.
Well, that's one of the reasons. Yeah. I mean, the most popular beer styles at the moment for craft beer tend to be hoppy beers, but you get more and more people looking at novel ingredients like using rye alongside your barley and your malt, looking at using fruits, say like fruit infusions into your beer. We do some barrel aging of beer, so you get whiskey barrels, which would have had interesting whiskey flavours, and wood and oak flavours. And when they take the whiskey out, we put the beer in. Look, a lot of experimentation. Doesn't all work, but lots of interesting stuff coming out.
There may be many types of beer, but the basic process is the same for all of them.
On the left-hand side is we have the mash tun. We'll add in our milled malt in there, and it's going to go through a process of hot water extraction, where hot water will just break down all of the starches in the malt and also extract colour and flavour to make a very intensely sugary liquid.
What does that taste like?
It's kind of like liquefied breakfast cereal.
Okay.
Yeah, that's exactly how it is, yeah.
That liquefied breakfast cereal is called wort, and it gets transferred to a massive kettle where it's boiled up. Hops are added for bitterness to balance the sweetness of this wort. The hops are removed, the liquid cooled down and passed into a fermenter. Yeast is added, which eats up all the sugar and converts it into carbon dioxide and alcohol. So how long has this been in here?
This one's been here for 2 weeks, so it's
2
just
weeks.
about there. We'll be judging it soon enough. Is it ready to go for filtration?
So at this point, you have to decide whether it's ready to go out or not.
Exactly, yeah.
Excellent, I'll help.
Okay. Are you ready to try it?
Yeah, go for it.
Okay.
Sláinte.
Sláinte.
Oh, wow. That is definitely worth all of the work that goes into it. The explosion of so many new styles and flavours is influencing our attitudes to beer and the way we drink it.
So now that you have a range of beer flavours, you can experiment with the range of food flavours and how they all work out. From cheeses to meats to to desserts. Stouts can go very nicely with a dessert. Certain darker beers, I think, pair really well with beef, and that's around. We spoke about roasting the grain and the kind of caramelised flavours that can come from the roast grains into the beer. They can match very nicely with, say, cooked meat, barbecued meat, roasted meats. That's something craft breweries are also very interested in, pairing local foods, local beers. A little bit like maybe tradition in France with wine and local foods.
That's our 10 things to know about beef and beer. Next week, we find out how developments in science and technology can help us to recover from sports injuries, learn how to prevent them, and improve our game.